So negative 0.71. If there's a fraction as your leading coefficient, I put that in a bracket usually. I put that in brackets, so I go top divided by bottom if it's 4/5, let's say. And so once we have this, let's graph it, see what we get. The window I had is doing a pretty good job. I think just to make sure, I'm going to increase X max a little bit. So I'm going to go to 15. And I don't know if I mentioned already, I don't want to see too much on the negative sides here. So I'm actually going to trim this out and the bottom as well a little bit. So instead of -10, I'm just going to go -2. Instead of y min being -10, I'm going to go -2 as well. So just a little bit to the left of the y-axis and underneath the x-axis. Hit graph. There we go. Let's read the problem before we start. While on the moon, an astronaut performs experiments that studies the path of the objects. She throws the baseball upwards from a platform 12 meters above ground. That right there is an important statement. We can verify that by looking at the equation and saying, oh yeah, it's 12 meters above ground. There I have, that's basically my y-intercept. And so where the height of the ball is h and the time is in seconds. Because of that, guys, everything in this problem is going to be time and height above ground. Okay, and time can't be negative, and height in this case cannot be negative because it says height above ground. So we're just above ground here. We don't care about the negative. So basically, time and height. We know it starts here, it goes up and lands on the ground, right? So that's our scenario. We're restricted to quadrant 1. How long will it take for the ball to hit the surface of the moon? That's happening right here, okay? That's your x-intercept. So we go let y2 equal to 0. We go second, trace, intersect. Let's do that. I don't care about the -1 here. Time starts at 0 and then it lands there. Enter, enter, enter. 10.12. So 10.12 seconds is the time it takes to get to this point here. So I'm going to put 10.12 seconds in my little sketch here so that I can refer to it later if I need to graph it. What is the maximum altitude the ball reaches? We're going to find this at the vertex. So here's, what am I doing here? Max. Here's what I want you to make sure you understand. So if this is a maximum, I need to go to the left of the max. That's the vertex, right? And enter, enter. The maximum is 4.23. Yeah, that's correct. 24.68. Please don't just leave it like that because you won't get full marks yet. Which one of these represents the altitude, the maximum altitude? It's 24.68. So you need to have a statement or just state that number with the units. Oh, it's not feet, it's meters. We're not in the US on this one. Here, 24.68 meters. That is how you get the full marks there. So this 4.23 would be like if it asks you how long does it take to get to the highest point, you would have selected the 4.23. Okay. What is the initial height of the ball? It's 12 meters. Okay, so it's the y-intercept. It's given to me by the 12, and that's why it's only worth half because it shouldn't take you that long to do. And then we graph it. I have everything I need. If I go to my sketch up here, I have 0.12. I have 10. This is technically 10.120. That's the coordinates of this. I do know my vertex. That's 4.23, 24.68. And now I'm going to do a proper sketch, right? So First things, time in seconds, height in meters, okay? So you have that labeled. Let's see here, 1, 2, 3, 4, and another 4, that's 8, and another 4, that's 12. So that actually works pretty good. No, it's not gonna work. Because I can only go up to 20, right? This would be 16, 20, it's not quite gonna work. Okay. So this is a fail, right? This would be a fail army loop here. 5, 10, 15, 20, 25. That's what I'm gonna do after all. I did that on purpose, okay? 25, that makes sure my vertex fits. In terms of the X, I need to make sure I account for the 10.12. So let's see here. I will do 5, no, I can do better than that. 2, 4, 6, 8, 10. I think that'll work. 2, 4, 6, 8, 10, because it's 10.12 is just past the 10 mark, so it's right there. The vertex is at 4.23. This would be 5, 4.5, 4.23 is right about there. And you go all the way up to 24.68 right there. And you start at 0, 12. This would be 12.5, because it's between 10 and 15, so 12 is right about there. So here we go. Beautiful. H of t, negative 0.71 t squared plus 6t plus 12. Take off half a mark if you forgot a label. Take off a full mark if you forgot more than one label. Okay, and then of course you need a mark for scale and shape. I'll bunch that up into one mark. So make sure you give yourselves a mark there. For the domain and range in this situation, there should be no infinities. For domain, I'm going from time 0 all the way to 10.12. That's your domain. If you chose to use set notation, you gotta go from 0, and you have to use t to do that one. That's your domain and set notation. For range, you go all the way from 0, because it does hit the ground, all the way to 24.68. That is your range. If you chose to do set notation, it's 0, h, 24.68. Okay, that's how that one would work. So 1 mark for each, 1 mark for domain, 1 mark for range. And we're approaching the end here. How long will the ball stay at or above 17.5? So that's where you do the second trace intersection. This should be a 2-mark question. We'll just keep it to 1.5 today. But really, you're wondering, if you draw your 17.5 line, it's from here to here, that time there that we have to find. So let's find time 1. This is time 1, this is time 2. You let y2 equal to 17.5. Graph it, second trace 5. Let's find the first one. That is 1.0462. You get half a mark for that. Time 2, I'll find that one, won't be on the screen. Go closer to that one, enter 3 times. That's 7.4045, half a mark for that one. And then subtracting them gets you 6.36 seconds. You get half a mark for that one. So half, half, half. Can I just talk about different ways to refer to these kind of steps that you need to take? It could have said, how long did it stay at least at a height of at least 17.5 meters? It's the same idea, okay? At least 17.5, you're like, okay, I need to figure out 17.5 or more. That's what I need to figure out, so keep that in mind. If we add all of this up, it adds up to 8. So make sure you have your total out of 8 at the top and your name and last name on there.